Welcome to Industry Focus. I'm Nick Seipel. This week, we're taking a look at additive manufacturing, perhaps more commonly known as 3D printing. My guest this week is Arjun Agarwal, Chief Product Officer of Desktop Metal. Desktop Metal is the most recent entry to the public markets in the additive manufacturing industry, coming public via a SPAC transaction late last year. Arjun, thank you so much for joining me.
Yeah, of course. Happy to be here.
Yeah, great to have you here. Excited to talk about Desktop Metal, the stuff that you're doing in the industry. But first, just kind of set the stage for our listeners. Folks have probably heard 3D printing, know what the word means, but probably aren't super familiar with the process. So for someone who's total amateur, maybe explain what 3D printing is and really what entails making something via this process.
Yeah, it's actually a much broader kind of phrase or industry than I think people give it credit for. I'll try to break it down at a really high level. The idea is to basically take a 3D object and to slice it up into hundreds, sometimes even thousands of layers, and then to create the object layer by layer so that at the end of this process, you have a 3D shape instead of, for example, like a stack of pieces of paper for a 2D printer. And the nuance is all in how you create those individual layers. And there's several different technologies. There's actually 7 different kind of high-level technologies that can be used. The one that people are probably most familiar with is where you take a nozzle and you extrude a material through that nozzle. And it basically, layer by layer, extruding a little bit of material, and then you move up and then you do another little bit of layer of material. And so you can create a shape that way. But there's a whole bunch of different technologies. And I actually think that that's a lot of where the exciting developments are in the industry is different ways to 3D print that allow you to do it faster, more cost effectively, and with higher kind of part quality, so resolution, accuracy, that allow us to finally take 3D printing from what's mostly been like a prototyping kind of application into more of a high volume, true, production manufacturing environment.
Yeah, so I'm glad you mentioned the kind of where 3D printing plays today is much more in this kind of niche products, prototyping side of the industry, and what your company's goal is to transition more from being that this more small run products towards full mass manufacturing. Why has the market so far today been stuck in this prototyping phase, and what are the barriers to really jumping to larger mass scale manufacturing?
Yeah, absolutely. I think manufacturing, first of all, conventional manufacturing, it's a massive industry. There's around $12 trillion worth of spend globally on manufacturing. And that's all primarily using conventional manufacturing technology. So think casting or forging or stamping or injection molding or CNC machining. These are all conventional manufacturing techniques, and they dominate that $12 trillion. 3D printing or additive manufacturing is roughly a $12 billion market. So it's like 0.1% of that broader pie. And the reason I think that it hasn't gotten to much broader penetration, there's really a few key barriers that you need to overcome, because manufacturers are looking at, well, I can make this via conventional manufacturing and I can make this via additive. And there's got to be some level of a comparison where you can say, from a material properties perspective, I'm getting a product that's going to perform just as well as if I made it conventionally. From an accuracy and part quality perspective, it's going to be just what I can get. From a resolution or surface finish perspective, it's going to feel like what I can get out of a conventional manufacturing. And I think the additive industry has done a really good job of evolving over the past few decades to kind of meeting the bars on many of those different aspects. The one that's kind of been really lagging is on cost and throughput. Throughput meaning how many of a given part can I produce? That is what I think has really held the industry and the technology back. And I think a big part of it comes from, it's on the spectrum. Manufacturing is decades, even centuries old, and 3D printing relative to that is still a new industry. And I think a lot of the technologies are still at the point where they're not super time effective, meaning in that example that I talked about earlier, where you're extruding material, a little filament through a nozzle, it takes a really long time to trace out every layer. And then think if you have hundreds of layers and each layer takes 30 seconds to a minute, even building a simple part can take a really long time. And so a lot of the existing, what we call legacy technologies out there are pretty speed limited. And that prevents you from being able to make a lot of parts and being able to make them cost effectively. And so I think that's where our focus as a company at Dust Up Metal has been, whatever the material is, whether it's metal or polymer, or now we do wood, it's all about getting to cost effective, high throughput production techniques and materials that enable those.
Yeah, so you talk about the speed of production, obviously super important. One other thing I wanted to talk about too is just precision, accuracy. When you're talking about broad scale manufacturing, there's sometimes very, very narrow allowances when it comes to these particular parts. Endemic, to the process of 3D printing is you have to shrink the materials that you make. You have the sintering process where there's this big change in size. So how do you think about allowances in the manufacturing business? So not only solving the speed problem, but also just the accuracy problem at scale.
Yeah, I think it's a great question. I think a lot of 3D printing technologies are actually very, very accurate. It's always a challenge. You're always going to have customers that say, I need this part, tighter tolerances. I need that part or that specific feature really, really tight. And I think generally speaking, the industry is improving gradually on that scale. There's a couple of ways to do that. You can do it in the hardware and in the process, which is certainly something that we're focused on and many other companies in the industry are focused on. Or you can do it in the software as well, where, as you mentioned, our processes, not all 3D printing processes have this, but our process on the metal side, binder jetting, that's the technology that we use to achieve really high speeds. And we have our own proprietary technology there. We call it single pass jetting. That technology, once you print a part, you have to actually put it into a furnace in order for that part to really turn into kind of dense, hard metal. During that process, there's a little bit of shrink. And so as you said, I think, customers can worry, is this going to actually be the size of the part and the shape of part that I want it? To some extent, that process has been around for decades. So there are established techniques for helping to get over the hump. But one of the things that we're doing that I think is really exciting is we've got a tool called Live Sinter. That's a software simulation tool that actually simulates that entire black box process that takes place in the furnace, where you have all kinds of different forces at play. You have friction, you have drag, you have gravity, you have thermal considerations. The parts are getting heated up to, 1,000 degrees C or higher. And so our software, in a matter of minutes, simulates what happens in that furnace. And it actually then takes that simulation and it runs through iterative loops to compensate for any shrinkage, any warping, any off tolerance that you might get. And it creates a print ready geometry. So our goal is to really improve the hardware and the materials and the process, but then to leverage software to get you that kind of final fit on the part. So you don't have to go out and print 20 different times and do a bunch of guess and check and, have a guy or a girl sitting there doing the CAD and trying to manually adjust things. We really try to leverage artificial intelligence and software to do all that work and make it a much more automated, simplified process.
Yeah, that makes sense. And obviously an important consideration for anybody in the production industry. So when you think about like the applications, so you mentioned earlier that, manufacturing is a 100-year-old industry. You've got companies with very, very developed supply chains. This is something that's going to probably gradually change over time. As far as the applications that are really perfect fit for your offering today, where are you seeing the adoption really pick up the most quickly? What industries?
Yeah, it's funny you ask. I think 3D printing has a legacy of serving aerospace and medical applications. And I think a large part of that is because the technology was a little bit slower, so it couldn't produce as much volume, but also it was more expensive. So you're really relegated to higher value, high cost parts that are in low quantities. So medical and aerospace fit really well there. What we're excited about is making 3D printing and additive manufacturing more cost effective and higher throughput. So we see a lot of interest from applications in industries like automotive, consumer products, consumer electronics specifically, something we're really excited about, but even things like fashion and accessories. We've talked about players in the jewelry industry or making handbag accessories. Those are interesting. Oil and gas, where you're doing maybe not, tens or, hundreds of millions of parts, but you're doing thousands, tens of thousands, hundreds of thousands of parts, real volume manufacturing. I think we see a lot of great applications there. And then just general precision machine components, where you have these precision component manufacturers all around the world, machine shops, job shops. There are hundreds of thousands, if not millions of these around the world, whether they're for profit or internal to organizations. And they aren't making just any one thing. They're just making a whole wide variety of different components. And on any given day, they may be doing 5, 10, 20 different jobs, all different geometries. And that is a really great use case for 3D printing, because the technology is so flexible. You don't need tools. You don't need a CNC machine programmer sitting around and, spending a half an hour or an hour more programming the machine for each specific geometry. You kind of just use the software, you upload your digital part file, and then you set it to print. So there is industry specific applications, I think, and then there's also use cases. One other one I'll just speak to on the industry specific. I think I mentioned healthcare and medical a little bit. I think there's a huge opportunity there that we're really excited about, particularly on the dental side. I think we see a large opportunity for not just things like aligners, but for permanent kind of dental implants, dentures, for crowns, restorative. So dental is a really interesting area that's cresting. There's a lot of stuff in the biocompatible area that we're excited about that's a little further out, but all of these are great applications in industries that are now being enabled because we can make the technology and the parts cost effective.
Right. So you can actually get your perfect custom made denture at a price that it's something that is affordable to an average person or for an insurance company.
That's right. And not just affordably, but in a timeline that makes sense, as opposed to having to sit for weeks. You go to the dentist's office, you get the mold done, and then they send you away. And 3 or 4 weeks later, you get your dentures. Now you can go in, you can digitally scan, they can put you under anesthesia, or they can have you in the chair. And while you're getting all this done, they can be printing out the part in the back room, install it there in that same visit, and you walk out the door with a brand new smile. The ability to, especially in healthcare, have patient-specific solutions and do it with really short lead times, I think is very powerful.
Yeah, so you talk about a lot of these different industries, whether it's aerospace or healthcare or any manner of others. How do you go about selling your solution? It sounds like each one of these particular customers would have a very, very narrow a set of needs. How do you go about making your case to this wide variety of customers?
Yeah, we've got a really great kind of go-to-market for Desktop Metal, and I think our focus is a lot on education internally. So a lot of what our sales and marketing team and our engineers are focused on is defining kind of really great lighthouse case studies for particular industries and application examples. So for something like automotive, or for something like oil and gas, what we'll do is we will actually go in and we'll canvas from our existing customer base. We'll talk to prospects, and we'll come up with some really great kind of key examples. We'll have our engineers design them up in CAD, consult with those other parties, and say, look, here is the part that you can make. It's a representative geometry, or it's a real customer geometry if they're letting us speak to it. Here is how much time it would take. Here's how much time it would take to manufacture one part. Here's how many you can manufacture in a week. Here's how many you can manufacture in a year. Here's how much it would cost to manufacture one of them. So it's educating them on the economics of the solution. Then you can have a discussion around, here's all the materials that you can manufacture with, whether it's stainless steels or low alloy steels or cobalt chromes. So we spent a lot of time and resources internally developing these lighthouse examples, application examples, case studies. And the way that we distribute those to the market, we at Desktop Metal, I think we have a really unique kind of distribution strategy through a network of partners. And so that allows us to have really great reach geographically, because manufacturing and manufacture, it's really distributed. It's a lot of small and medium businesses. They want to see, touch, feel, see the parts. And so we make it a big part of our education initiatives, not only distributing great content and doing webinars and helping people understand, here is what you can make, and here's the art of the possible, but also actually trying to get them to see and feel and touch the process themselves.
Yeah, that makes sense. I think from there, I want to talk about your product portfolio. You've rolled out a number of new products this year. Later this year, scheduled to roll out your P50 production system, which ties into all what we've been talking about as far as speed and building into new supply chains. can you kind of put your kind of products offerings in context for folks? You have a number of different offerings. You also acquired a couple companies over the course of this year. So you got kind of from a 10,000 foot view, explain your product portfolio to folks who haven't studied your business.
Yeah, so we now have additive manufacturing solutions across a variety of different materials. Those range from metals to composites to polymers, elastomers, wood 3D printing, sand 3D printing. So, I'll first say, if you have any use cases or any interest in additive manufacturing and you make one of those materials, so biocompatible is the last one I would add to that list. We've got solutions. And then, what those solutions do, we have a range of different price points ranging from, just a few $1,000s to kind of our larger, more industrial systems. And all of these systems are really focused on enabling end use parts production. And the form factors and the price points of these different solutions basically vary based on what kind of throughput and what kind of economics you're looking for. So we have everything from low medium volume solutions for end use manufacturing to mid volume. On the metal side, our shop system is great for that kind of mid volume, batches of hundreds of parts or thousands of parts. And on the polymer side, we've got the Envision One and the Envision One HT in kind of a standard and XL format. And then we've got our kind of super high volume, really industrial manufacturing platforms. That's like our P50 on the metal side, our P1 on the metal side. It's a really interesting, great for development for that industrial scale manufacturing. And then on the polymer side, we've got our Extreme 8K solution as well. So we've got, I would say our portfolio is really broadly focused at enabling end use parts manufacturing, not just in low, medium volumes where traditional 3D printing has been focused, but now for medium, super high volume 3D printing as well. That makes the technology cost effective and easy to use. That's a big thing for us, is how do we lower barriers? So we've got all of the stuff you need to get started: software, the systems, materials. Many of our solutions are turnkey, and we do this across a wide swath of materials.
Yes, when you talk about that P50 system coming later this year is going to be a really high-end production system. What's the price point for this system? If somebody wants to go buy this and put this into their factory, how much are they shelling out for it? And how do you end up making money on this as a business?
Yeah, so we don't typically talk too much publicly about our ASPs, but I'll say, the printer alone is going to run you, call it high six digits on that one. And we've got a whole bunch of different configurations as well. So depending on if you're going to run it once a day, once a week, or 24/7 lights out, the price ranges. So there's no, one specific price for the system. It all depends on how you're going to use it. And I think, with respect to how someone's going to get this and install it and use it, there's a big part of it that's facilities. If you're buying an industrial manufacturing piece of equipment, you need to invest in the right facilities. There's some ancillary equipment that may be required. But then, it's a process of installing, getting up and running. I don't think someone should expect to install the system one day and, the next day being able to turn out parts 24/7. But transparently, that's a big part of what we're trying to enable. And that's where our software comes in. So it's learning the process. If you've never done 3D printing or never done binder jetting before, learning how to design parts that work really well with that process. Conventional manufacturing has all kinds of limitations on geometries, whether it's undercuts or, if you think about CNC machines, it's really what you want is 2D projections. Otherwise, you need all kinds of fixturing. But 3D printing allows for really complex geometries. But at the same time, to really take advantage of the benefits, you may want to tinker with your designs a little bit. To both get performance benefits and to reduce material usage and to increase yield. So there's an element of, all right, how can I best use the technology to actually enhance my performance? So there's, a little bit of that. And I think that, with the facilities, with the system, with some design expertise, customers should be up and running, hopefully pretty quickly with their new industrial manufacturing processes.
Yes, so I mentioned those acquisitions that you made earlier this year. So Envision Tech, a $300 million acquisition, X1 just earlier this month. You're looking at $600 million acquisition there or so. So What's been the motivation behind these acquisitions, especially coming so quickly after your IPO? Was that contemplated as far as coming public to get access to capital to go gobble up some of these companies?
Yeah, I think that was always a part of the story. Is we saw coming to the public markets as an avenue to increase our capital base to go out and affect some acquisitions that I think we thought were additive. Broadly speaking, we're looking at a growth strategy focused around a couple of different key pillars of the business. That's great, high volume focused 3D printing platforms. That's companies that create unique and differentiated materials so we can vertically integrate into the full customer supply chains, make it more cost effective and more tightly couple the hardware to the materials, because that's the way that you're going to get the best results. And then the third key pillar is around killer applications, and where we see really killer apps for additive manufacturing, where I think the technology allows for much higher degrees of performance and a much more kind of allow the parts manufacturer to capture more economics to then leverage a fully vertically integrated supply chain across systems, materials, and parts. So these are really kind of the three key pillars that we think about growing and advancing at the company. And I think each of the acquisitions that we made have played into that, whether it's EnvisionTech and X1 and Aerosent. These are really expanding our print platform technology. So EnvisionTech brought us into polymers, and they've got to focus on volume production in polymers. X1 we love. It's very complementary. I think they've got great technology, really highly flexible on the bindergenic side. It's a great complement to our very high throughput systems. And on the same 3D printing side as well, they've got very high performance, high quality systems that are a nice complement to our, low cost architecture, robotics and 3D printing systems. So I think there's a lot of complementary nature there. Aerosent, multi-material. We see Aerosent as potentially, a really great future of 3D printing, where people are not only going to need to print parts, but also print full products. And that might be multi-material. So, it's a lot of looking at different print technologies. That's one area where we play. Another area is around materials. And, Adaptive is a great example of that, where we acquired, we think our best-in-class elastomers to help funnel those through our 3D printing platform. In fact, we're really excited about bringing adaptive elastomers to market right in concert with our new EnvisionTech platforms, the Extreme 8K in particular. So, it's a strategy we continue to evolve. I think we've been pretty strategic about where to deploy our capital, but I think in every case, we're trying to make decisions that over a 10-year time frame are going to allow us to capture double-digit share in the additive market, which, is projected to be at that point in the 2030 time frame, well in excess of $100 billion. Estimates range from 100 to 150. So our goal and all the decisions that we make today and how we deploy capital is, let's make sure that we have double-digit share on that 10-year time frame.
Yeah, let's talk about, the 5-10 years down the line, that the future of the industry. You see some consolidation happening here, lots of excitement returning to 3D printing. There was some excitement, earlier part of last decade that didn't necessarily materialize. When you look forward the next 5 years or so, why is now different than what we saw last decade? And what are you most excited about going forward?
Yeah, I think 3D printing has definitely gone through a hype cycle. There's no doubt about that. I think the big thing today that's different from back then is the thesis on what's going to take 3D printing to the next level. And a lot of what we're focused on, we call it additive manufacturing 2.0. It's a term that we kind of coined as we came to market. And it's really all about volume production of end use parts. I think, and we think at Desktop Metal, that's what's going to take additive manufacturing from 0.1% to 1% of the overall manufacturing, with still a lot of white space. By the way, that's 99% that we still haven't captured. But even a 10x increase in size in the market is massive for us, from 12 billion today to more than 100 billion. And I think that's all around technologies and solutions that allow businesses and manufacturers to use 3D printing for volume production of end use parts. And I think that's where it's really different from prior iterations of 3D printing and earlier on in the hype cycles, where it was companies that were focused on solutions that and technologies that I think were better suited to prototyping or tooling pre-production use cases. That's great. There's great technology there, and there's still a lot of opportunity in that market. But if you think about bringing, businesses bringing products to market, the vast majority of spend that businesses have is on when their products are actually in production, not on when the products are in pre-production and in prototyping phase. So that correlates in terms of how they spend on equipment and how they spend on materials. And so, I think there was, we call it additive 1.0, a set of technologies that were just better suited to low volumes and prototyping. And they were never going to be able to make that leap to volume production because the throughput wasn't there and the economics weren't there. So I think people got really excited about this idea of everyone's going to have a 3D printer in their home, and my TV breaks and I'm going to print a new part, or my swing set breaks and I'm going to print a new part. And sure, maybe there's a little bit of that out there, but I think we really believe that what's going to take this technology to the next 10x level of growth is enabling it for mass production or volume production use cases of the actual parts that consumers are going to use.
Right. Yeah. So this isn't something that you're going to have at your house, print something out to fix your TV, but it is something that Ford is going to have to, produce a product to make their truck compliant in another jurisdiction, or get to that next level of performance on their new vehicle or something like that, or an F1 team, maybe.
Yeah. I won't say no one's going to have a 3D printer because I have a 3D printer at home that I use to fix random doodads. But I think, there is a limit to the market growth when that's the case. And I think where we see the biggest economic opportunity is in real manufacturers, like you said, the automotive tier one OEMs, or your consumer electronics manufacturers, or your consumer, fashion and accessory manufacturers, or your oil and gas companies. When these people start to use the technology to actually make parts that they are then providing to their end users, that is, I think, what's going to create the next explosive level of growth. And, we see it in all the surveys when we talk to customers, and all the third-party data will, say, hey, X% of people use 3D printing for volume production of end-use parts today. That's like in the single digits or in the low teens, and it's 50% want to do that over the next 5 to 10 years. That is a huge delta, and that's what's going to drive a lot of the growth of the adoption of additive manufacturing.
Yeah. So you tell the story of really reaching a more mature industry, still, compared to the overall manufacturing industry, still a small contributor, but with lots more opportunity to grow. So as you see the overall industry maturing, I think we'll see probably Desktop Metal's business mature in some ways, still not profitable today. As you look out towards, the continuing evolution of the business, what do you think about the path to maturity from a cash flow profitability point of view for the business?
Yeah, I think today we're focused on really capturing the massive opportunity that we see ahead from a growth perspective. So as I mentioned earlier, but all the decisions that we make, and as we think about cash flow and profitability, we're not going to, we're going to make sure that the capital investments and the decisions that we're making are what we need to ensure the long-term health and success of the company, and grabbing that double-digit share over the next 10 years. And that may mean that we'll continue to invest. That may mean at some time that we anticipate, becoming profitable. We haven't really commented publicly on kind of those timelines, but I think this is a growth story. We see a huge opportunity here that we want to capture, and all of the decisions and investments that we're making are with that in mind, that across many applications, we are really seeing industries, just at the beginning of the S curve where the adoption it's been slow and it's just starting to tick up, and we're trying to position ourselves to best capture that acceleration in those S curves as the technology gets adopted more widely.
Yeah, makes sense. Arjun, thank you so much for spending this time with us. Maybe one last question before I let you go. So we've talked a lot about Desktop Metal, different aspects of the business, the industry. If you wanted to leave potential investors or folks who are interested in the industry with one or two final thoughts, things that they should definitely take away from this conversation, what would those things be for you?
Yeah, I would say additive manufacturing is going to be big. I think there's a big difference from the last go around. It's all about, what we call additive manufacturing 2.0, volume production, end use parts. And it's all about going to market with cost-effective solutions across a wide swath of materials. And I think that that's what our goal is. And I think that that's what's going to grow the market. So we're really excited to be, solely focused on achieving kind of this goal and bringing the technology to much broader adoption.
Well, Arjun, thank you so much for spending this time with us. I'm excited to watch what Desktop Metal does here in the future, and I hope we can stay in touch.
Sounds good. Thanks so much, Nick. Great talking to you.
Awesome. As always, people on the program may own companies discussed on the show, and the Motley Fool may have formal recommendations for or against the stocks discussed. So don't buy or sell anything based solely on what you hear. Thanks to Austin Morgan for his help mixing the show. For Arjun Agrawal, I'm Nick Seipel. Thanks for listening, and Fool on.